Alright, welcome back. In this video, we are going to create a Fabrics notebook. Notebook is one of the principal components of a modern data engineering solutions because with the notebook, we can read data from multiple different source systems, which is, for example, in our case, is ADLS storage. We can do transformation. We can also do data enrichment analysis, and we can save the output to the destination, which is the bronze layer of the Fabrics Lakehouse in our case. As we saw in the previous video, our file or our data is in CSV format. So we are going to read this data using spark.read operation. We are going to explicitly define a schema, validate, and check the overall output. And then we want to make sure that our notebook handles incremental loading using merge operation. Also, we want to make sure that if the notebook is executed for the first time, it should check the existence of the delta table. If it doesn't exist, then it should create the table and do the initial load. And for all the subsequent run, the notebook should do incremental loading. This is a very real-world scenario that almost every data engineer encounters in the enterprise environment. We are going to learn a lot from this video. So without further ado, let's jump right into it. Okay, so here is my Fabrics portal. So let me go to the workspace and then click on new item. Click on notebook, give a name, then create. All right, so we need to attach the notebook to the Lakehouse. For that, just click on this green button from catalog. Then choose your Bronze Lakehouse. Mine is right on top here. Select that, then add. Okay, so while that's connecting, with this notebook, what we are going to do is basically we are going to read our data. The data that we've got in the ADLS storage is in CSV format, as you remember. We are going to apply some schema validation, and then we will create the bronze table, which will be stored in the Bronze Lakehouse here. But before that, we need to understand the file path. So what file path are we going to use to read our data? In Microsoft Fabrics and other storage environments, there are generally two common ways of referencing a file. And the first one is the HTTPS path. And this one normally have this kind of protocol. So this type of path is mainly for a browser-based access. For example, if you have a paginate report or a Power BI report and you published it to the web, so you can create a HTTPS path and share it with your colleague or your user so that they can access the data on the web. And also for REST API or API request. So those kind of reading data require the HTTPS path. For manual download or any external integration, normally the HTTPS protocol is the preferred way of reading the data. The second option is the ABFSS path. And this has this kind of protocol where ABFSS container add storage account .dfs.core.windows.net, then basically the file path here. So the ABFSS stands for Azure Blob File System Secured, and normally for our work, as we are working in Fabrics environment here, this is the preferred method. Not only in Fabrics, but for any data engineering activity in Azure Synapse Analytics or in Databricks or any kind of PySpark workload, the ABFSS path is the preferred protocol. The reason is that the ABFSS protocol is optimized for a distributed big data processing, and it provides some better Spark integration. Also, it gives some secured authentication, parallel processing capabilities, as well as it has got improved performance for any analytical workloads. So in this demo, we are going to follow the ABFSS protocol. Okay, so following this, the ABFSS protocol, let's define our file path. So let's give a name for our file path. So AD ls file path is equal to container. Our container, like as you remember, is landing. And then the storage account, if we go to our resource group, and then for the storage account, that's the storage account here. So just copy your storage account and then paste it there. .dfs.core.windows.net, and then the folder, if we go back to the same place where we were, that's the container. Then address, date, and then the file. So those two are the folder and subfolder. And then the file name is basically this one over here. Then everything has to be in the F string. However, it's, this is not really the best practice. We have to parameterize the file path so that when we do the migration from the development environment to the production, everything will be dynamic, because the container name might be different in both environment. The storage account might be different. So we need to parameterize this path. So the different components of the file path will be picked from the parameters. So let's define the parameters here. So for example, the directory name, that is going to be landing. So in the same way, I have everything written here. So the ingestion date is basically this one over here. So we've kept the different component of the file path in a parameter. So let's make the path to point to those parameters. So for that, we have to put it in the curly braces, each of them here like this. Okay, so the file path is very much dynamic now. So if I say print ADLS path and run it, here is the file path. So ABFSS landing storage account. All right, that's good. Now let's read our file. So if I read CSV data using, so we're going to define a data frame. df is equal to spark.read. Our file is in CSV format, and then we have to give it options. Our file has got a header. So header is true. And then for now, we need to infer the schema, but later on we will define the schema. And then load basically. So let's reformat this thing a little bit. And then display the result once we read it. Okay, so we have the data here. That means we are able to read the data from the ADLS storage into the Fabrics environment. The next step is, let's have a look at the schema and then check what the inferred schema look like, and then we'll define our own schema. Okay, so let's see what the inferred schema look like. So for that, we're going to say df dot so not infer but print schema and then run it. So these are the schemas that are automatically detected by Spark, and it's pretty good. I mean, you can see rs ID is detected as integer, which is this one here. rs line 1 string, which is this one here, and that's not bad. That is modified data as a timestamp, which is good. However, in enterprise environment, relying on inferred schema is not the best practice. The reason is because schema inference can sometimes misinterpret data types. What does that mean? I mean, if you infer a text numbers, let's say you've got a text within a field, but all of them are numbers, like a postal code, for example, that's a number. Infer schema most of the time detects those kind of data as integer. This one, for example, is detected as a string, and that might be because there might be a string field within this. We are only seeing the top 3 rows here, but there might be some text field within this data set. That's why it's detected as string here. But if the whole record of this field is numeric, then infer schema detect this one as a number or integer. But we don't want that to be integer, because postal code is often a string or a text data type. So because of that, data types with infer schema can be misinterpreted sometimes. Also, because it's a one more step for the Spark engine to read the data infer the schema, the performance can be slower, especially for a larger data set. So for that, I think it's better to define our own custom schema and use it in the Spark.read processes. Also, if the file coming from the source is inconsistent, and we directly read that file and use infer schema instead of using a custom schema, then that might also cause the overall failure of the reading processes. So those are some of the reasons why we don't use the infer schema. We need to define our own custom schema, and for that we're going to use some of the Spark system functions like StructType and StructField, and define our own schema. Okay, so let's go ahead and define the schema. So address schema is equal to the data type is string type, and then it's a nullable field. So struct field address string data type, so I have to put that in. And then is it nullable or not? Yes, it's nullable, so I just put true there. So in the same way, I have defined all the other one. So if I run that, so I have to define the types here. So let me bring the function here. I think this is what I need. String timestamp. So run that, and then run this. RSID is not defined, so this has to be in. Okay, so I have my schema ready. Let's read the file using the custom schema. So if I copy that again and bring it back here, I just need to change that. And then basically this is my schema here. Okay, so we read the file, and you can see rs is data type is a string here, and everything is as expected. So that's a timestamp. That's good. Now we got everything ready here. So at this stage, if it is a one-time data load, for example, we can write this output to our Lakehouse, the Bronze Lakehouse, and let's actually do that. And then later on, we can come back and enhance the process to do incremental load using the merge operation. So to write this output to the Bronze Lakehouse, what we just need to do is basically use the write functions. So df dot write dot we have to mention the format. So format. Everything that you write in Fabrics is in Delta format. So let's mention Delta here. And then, you can use few more operations, like for instance, merge schema or the mode, for example, mode. We can mention overwrite. And then basically save. Save it to a path. So we have to define this path. What is this path? Just like the ABFSS path that we've defined here, we need to define the Lakehouse path as well. So I will attach the link for this path, Microsoft documentation link. But normally the Fabrics Lakehouse path for any Lakehouse is workspace name at onelake.dfs.fabrics.microsoft.com, and then basically the Lakehouse name as well as the schema and the table name. So that is how we can write the protocol for the Lakehouse file path, but this has to be in the F string. But we have to bring the workspace name just to be sure. So if I run that and maybe check the path for tutorial div, yep, that's it. But however, we haven't created the schema. So there are multiple ways of creating a schema for our Lakehouse. I mean, this Lakehouse at the moment has got a DBO schema and test schema, so we need to create a bronze schema. So for that, I think we need to go to the Lakehouse itself. This is the bronze here. And then from here, we can create the schema easily. Otherwise, you can also go to the SQL endpoint, and then you say create schema name. But it's easier to create from here, so I'll just go ahead and new schema, bronze. So I have my schema here. Let's go back here. So everything is ready. And then if I come here, maybe let me just get the path name. And then put it here. I think that should write. Okay, so that is the file is written to the Lakehouse successfully. So let me refresh and check it. So here is the bronze schema. So within that, we've got the table here. So if I cannot, I can drag it and drop it here and run it. So that is it. Even if it is a one-time ingestion, we should have used this approach, override approach. But we don't want to override the file every time we run this notebook. So we want to load incrementally. That means if there is a new record, we want to insert it to this table. If there is an updated record from the source, an existing record with updated value, we want to update. So for that, we are planning to use a merge operation, and that way everything will be loaded incrementally. So let's see the merge operation, but otherwise the data looks okay. So you can see everything is clean and nice. Incremental loading with merge. So now comes one of the powerful features of Delta Lake in Fabrics, and that is the merge operations. So with merge operations, we can incrementally load our data, which means that we can insert if there is a new record, and at the same time we can do updates if the record exists in the target table, but the values are changed. So that is one way to incrementally load our data from source to destination. In Fabric's notebook, we can write merge operation in two ways. One is using PySpark. The other one is using the SQL statements, and that's what we are going to use in this demo. So to write our merge operations using the SQL, let's just convert this cell into SQL first. So %% SQL. And then we basically need to write merge into target. That could be as T. Then using the source table. So using source. And then we have to have a condition that can join the two tables, the source and the target. So that's going to be on some kind of condition, basically. So on some kind of condition. So based on this condition, when the keys are matching, so that is when matched, then we want to update some values. What about when not matched? We want to insert. So when not matched, we want to insert. Basically, you're going to list the fields there. So that's basically the merge operation. So you can expand the condition here. So when matched, and for example, date of ingestion is greater than today, for example, greater than record today, or when matched and sales amount is not zero, something like that. And also you can do the same thing for the when not matched and expand the merge operation. So that's basically how we do, how we perform merge operation in a Fabric's notebook using a SQL statement. And in essence of time, I've got the whole code written here with the fields and everything. I am going to copy it over. So merge into the source table. So the source table is the TBL arrays, which is this one here. And I created a view here because the source data is coming in the form of data frame, isn't it? So we've defined the source data here. So div is called spark.read, and then that's going to the Azure storage and get the data. But we need to keep the output of the data frame in a view so that we can use it in the merge statement. So to do that, I just say df dot create or replace view or temp view, and then basically you can just keep your view name there. So that basically keeps the output of the data frame into a view, and then we can use the view in the merge operation. And then the primary key for this table, well, how do you know which one is the primary key? Basically, you need to refer to the data dictionary that's coming with the data that you are working with, or also you can just write a SQL statement like %SQL, and then check which one is the primary key. If I copy this, and then maybe check the address ID if it's unique or not. So I say address ID, counted, and then group by address ID and check if there's a more than one record. Having the count if there are more than one record of the address ID. That way you can check whether the address ID is unique or not. Yep, it's unique here. And then when matched, do the update. When not matched, then do the insert, including the primary key, which is the address ID. I have added one more field here, which is the ingestion date. And this is coming from the variables we defined above, which is here, ingested date. So that's basically the merge operation. Now I cannot run this one now because I don't have this defined in this table here, unless I commented out this maybe. Maybe just let me remove that. And then remove this one as well. And let's check it. Yep, so I have one error here. So when merged, then do that. And then when not merged, address ID. Okay, so I think, well, I forgot to remove this one here. So that needs to be removed. Run it. All right, so the merge operation completed successfully. So you can see 455 records affected, and all of them are updated. There is nothing, no row deleted, and no new row inserted. Okay, so the merge operation works perfectly. But now we want to make this code rerunnable. What does that mean? Basically, whenever the notebook executes, it needs to check if the table exists or not. If you're running this notebook for the first time, this table does not exist. So what we want to do is, if the table does not exist, then we want to handle the table creation and initial load. So the code is rerunnable, whether it's a first-time load or subsequent follow-up run. So to do that, first let me change this back to the first code, the initial code. So we'll have the ingested date here, but we have to also add additional DTL statement here, which creates the table if it doesn't exist. So that's basically a DTL statement, create a table. If not exist, then the table name basically, where should I get, here is the table name. And then you basically need to list all the fields here. So in instance of time, I have the table creation statement here. So create table if not exist, then there's a table name here. Then all the fields, so address ID, string, according to the schema definition and everything, everything is here. So put a close bracket here. So that will create the table. When the table is created, we want to make the initial load using the insert statement. That's just a straightforward insert statement. So I have the query for that as well written here. Okay, so when the table is created, we are going to insert the data into the table. That's the initial load. Then it's reading it from the view, basically. That view, remember, it was defined up there. So this is the view here. That way, this code, this notebook is rerunnable. If you're running it for the first time, basically it will create a table and then it will insert it. If when you're running it for a second time, since the table exists, it will go ahead and do the merge operation. And all of these are going to be executed from a PySpark code. So we need to keep these things in a variable. So let's define a variable here. So the merge operation will be merge statement. Merge is equal to f string and then three quote here. As well as this one, we're going to put it in the merge statement, sorry, in a variable. So create table. And then close it here. Same thing with the insert, which is the initial load. F string. Right, so we have the SQL statements in a variable. Now, Now we'll go ahead and write the PySpark code which executes those SQL statements. And for that, we are going to use the PySpark functions that's going to go ahead and check the table whether it exists or not. If it does, then we will ask the code to run the merge operation. If it doesn't, then we'll ask the code to create a table and do the initial load. So that is going to be if spark.catalog, if spark.catalog.table exists. And then we put the table name there. I think we've got the table name in a variable. That is a variable which holds the table name. Then if that's true, if this is true, then let's print table exists. So which table? Table name. Since the table exists, we just need to spark.sql, then the merge operation, run the merge operation. All right, that is if the table exists. What about if it doesn't? Let me just say as well print the else part of the if statement, else. Then let's say print table does not exist. So then we'll just do spark.sql, then the create table. You can add your print statement is here if you want. Table is created, and then we'll continue with the next one when the table is created, spark.sql. Initial load. Then maybe finally here, print. Okay, so that will handle the the executing the SQL queries from the top here. We may need to bring some of the functions here for delta table. So from delta.table, import delta table. Yeah, that's it. So basically what this PySpark code does is that it will go ahead and check if the table exists here. If it does exist, then it will do the merge operation. If it does not, then it will create a table and then do the initial load. Now it's the testing time. For that, I'm going to remove this table, delete it. Okay, now there is no table. And then execute that, but let me do execute from here. We don't need to execute that. And that's not necessary. This is not necessary too. And then run. Delta module naming. So I think it's delta.tables. So you can see does not exist. So it automatically jump from here to the else part of the if condition, and delta table does not exist. Then it will create a table first, and then when the table is created, it will load it. Then initial load completed. Yes, so the initial load is completed. So if I come here and refresh, we've got our table here, and if I drag it and execute it, I check the output. We have the output here. So if I go to the end, there is an ingestion date here. All right. So yeah, we basically demonstrated everything from end to end using the Fabrics notebook. So we sourced our data from the ADLS storage. We used the ABFSS protocol to read the data. We explicitly defined the schema, and we incrementally load the data from source to destination using the merge operation. That is good. In the next video, we are going to orchestrate the notebook using the Fabrics pipeline. We are going to pass the values for the parameter from the pipeline and automate the whole process. This is it for this video. I will see you in the next one. Thank you. Bye. We